I'm Gianluca Arbezzano. I work as a site reliability engineer at InfluxData, and I'm here to speak about integration tests and how to write them using Docker in a way that doesn't feel like a painful experience. So, a little bit about myself. I'm a developer, I'm a Docker captain, and I'm a CNCF ambassador, mainly because I like to share and I learn a lot from what I do every day and chatting with other people about what I do and what they do. So I blog about distributed tracing, observability, container, and cloud, and I'm an active Twitter, so you can follow me and ask me questions or just follow my rambling around if you don't have anything to do. I'm really happy to make dirty hacks that looks great. So as an SRE, hacks are my daily job. And when I'm not hacking, I grow my vegetables. I come from Italy. I have a garden. I grow vegetables and tomatoes and all other vegetables. And I like to travel for fun and work. So InfluxDB is just across the street. And so I'm here to work and for fun. And that's the best I can get out from a conference and a trip. We are also having a meetup tonight, so if you don't know where to go, we are over there. But let's speak about testing. So for a good amount of year, I thought that testing was a solved issue. We have libraries and frameworks that help us to write tests in almost every languages. We had a lot of people, and we have a lot of people that speaks about BDD and TDD, test-driven development, and all this kind of stuff. So I thought it was a solved issue. But, this was a great time when we had Linux, Apache, PHP, and MySQL, and everything was running around WordPress around PHP. We didn't have, at the time, a lot of integration points. Yes, we had a database, but the database was there. We had a set of applications, but now it's all different. Now when I look at an architecture, I see something that is really, really different compared with the LAMP stack. So this is not an architecture that I can explain because I wrote on Google AWS architecture, and that was the first picture. So I presume I think it's a WordPress site that scales very well. So but my point about this issue about this picture is that our applications are way more complex than what we are used to be. And they grow and grow in complexity, mainly because we have a lot of integration points, a lot more integration points compared with what we are used to have. So our applications are speaking more with our cloud providers because all of them has API, or they speak with Kubernetes and our orchestrator, or we have third-party services like Auth0 to manage authentication, or we manage logs in Influx Cloud, or we have just a lot more tools. Maybe we have feature flags, and we have as a service tools that manage all our feature flags. So there is a lot more integration and a lot more going on. And when it's not a third-party services, maybe it's ourselves that we are developing microservices application. So microservices are not in the same process of our main application, and we need to talk to them, and we need to figure out what's going on. Sometimes they changes, and we don't know about them. And if we mock everything, we don't know when it changes. So it's still an integration point, and it's a pain to test. We also have a lot more databases. We are used to have, like I showed you before, MySQL, but now we have NoSQL, we have document store, we have GraphDBs. So we have a lot more of them. We have key value store. So Redis, MongoDB, all of them are used from many applications, and we need to test the integration with the database. So mocking everything is not something that we can do anymore, or at least it's not something that we can rely on to understand if our application is working correctly, because we have way more around our application than what we are used to have a few years ago. So a little disclaimer, don't go back and talk to your boss that Gianluca told you to not write unit tests anymore, because this is not the point of my talk. Unit tests are great. I write a lot of them, mainly because they help me to iterate faster on the code I'm writing. So when I think about a function that has a lot of conditions, a lot of loops, it's complicated, but it doesn't have a lot of integration points, so it stays where it is. It's very good to start with a unit test. because we know what the function takes as an input, we know what we want at the end of the computation, so we write the test and we iterate on the test until our function returns our result. So that's great, and I write unit tests, so you should do the same. As I said, unit tests are, I think, a solved problem, because we have libraries and framework almost for every languages, and they are all well documented. So I think it's a problem solved. If you work in Java, you have JUnit. If you work in PHP, you have PHP unit. If you work in Python, you have unit test. If you work in Go, there is a package that is inside the language, so you can do whatever you want. I think that integration test still has some flakiness or some issue that we can solve. So when I think about integration tests and I see how teams handle that, usually they do Docker Compose up, and when all the containers that they need are up and running, they do make test integration. And the test runner goes one by one over all the test case, and it reaches the Docker Compose containers to validate if everything is good. So there are a bunch of limitations that I see with this kind of approach. One of them is orchestration. Docker Compose is great, but sometimes we have a lot of different services. Sometimes we need to test them across multiple versions. So how do we do that in Docker Compose can be a limitation. Another problem is how do we validate that the service that we are reaching to and our integration is pointing to is working and is ready to handle the traffic. So sometimes a lot of tests are just failing, not because the service is not there, but because the container with the service is catching up and is not ready to handle the traffic. So all this stuff increases a lot the feeling of flakiness in integration tests. And another bad point is that there is no parallelization, or at least the parallelization is very hard to do. Because when you do Docker Compose, you have one instance of your services, of your service, and usually what you do is you store your data, you validate the data that are in, you make your stuff, you run your test, and you validate what's left. So this means that you need to run your test one at a time. Or there are people that hack solution, like if they are testing on MongoDB or MySQL or a general database, every test runs in its own database. So we are sure that we can run them in parallel and the data won't collide with them between themselves, and our test will fail by consequences, because all of them are pointed to a different database. But I think we can do way better than that. So a very important key to do better, I think, stays in the API. So we need to remember that almost everything nowadays provides an API. And often, as a developer, we use those API, and that's why we have so many integrations, because we have so many APIs. So you all know how Docker works, but I'm just going to repeat myself over and over just to be all on the same page. We know that there is a lot more over the Docker run than the single CLI. So when we do Docker run or when we do Docker pull, we reach what is called a DrD, and it's a server. It's a daemon that will take the request that the Docker CLI emits and will make the work for us. So when I think about Docker, I think about it as an onion. So this image is not made by me, by myself, but it's a very important image that stays for really long in the documentation, in the Docker documentation itself. So think about Docker as an onion. So you have the Docker CLI, that is the fancy user experience that Docker provides, but every request goes to a REST API and a daemon that runs in your host. So that's it. And even more complicated, this is another slide that I didn't do. It's an image that I took from the containerd documentation. Inside Dockerd, there are way more binaries and way more complexity than what we just see running Docker run. So there is containerd that handles all the life cycle of the container. There is runc that runs the actual container, and so on. And all of this stuff has an API. But what I'm going to stay focused on today are the Docker API. So this is just a disclaimer to say that Everything has an API, and I see a lot of developers that are scared to use the API because in their mindset, everything that they need should be provided by somebody else. But as a DevOps, all the DevOps culture is about providing the best workflow for the team and for your people. So the API plays a key role on that. This is one of the famous, example that you do when you start to do something that is not just the beginning of Docker. So you run Docker inside Docker. So if you use Jenkins for your CI, or if you use other tools, you usually end up running a container and you share as a volume the socket of your host, your Docker host, and everything that is inside the container and reach to Docker will speak with the one in the host itself. So it's not magic, it's just that you are sharing the entry point for the Docker daemon. And this is great when you do testing because you have your Docker engine in your host, you share the socket with the container that runs your specific test, and when your test suite is over, the container is gone and you are clean and you can move over. We need to remember that Dockerd has a configuration. By default, it communicates over the Unix socket, as I showed you before, but you can enable the TCP version, so you have a REST API that you can reach from the outside. We need to remember that it's a security issue if you expose your Docker daemon to the outside, because usually it has root access to your server, so bad people can do whatever you want with it. So if you need to use it, it's a good practice to log into to the same host network or to the private network. But be careful about when you do that. When there is an API, usually there is a client. So Docker has an API. It means that Docker has a bunch of clients. This is an example that I put together from the Docker SDK Ingo, but there are SDK for every languages, and they all work almost in the same way. So what's happening here is that we are creating a new client from the environment variable. So if you hacked a little bit with the Docker CLI, you know that if you need to point your CLI to a new Docker engine that is not in your local host, you can use a bunch of environment variables like Docker_client or Docker_token, and it will be pointed to another source. So this is what we are doing. We are just taking the environment variable just like the Docker CLI does, but we are doing that inside an application in Go. And when we have our CLI, our client configured, I'm doing the image pull from an Alpine. So using the SDK, you have all the power that you usually have with the Docker CLI, but you are not using the Docker CLI. You're using the code, the API, and you can do whatever you want with that. So this is it. This is a game changer when you realize all of this stuff. I know that we use them every day, but it's very useful when we step back and we look at ourselves and what we do every day, and we start to realize that we can play a really good game with them. And this is how I think integration tests should be written. This is at least the last way I learned and the way I like to write unit tests. So this is a Python example, but during the talk I'm going to go over a bunch of other languages like Java and Go. So we are creating a new MySQL container from an image from Docker.io, and when it's ready, we get the connection URL, so we get the IP of the container, and we execute a query. So this is the flavor about what we are going to speak today, what we're going to see today. Yeah, it looked like magic. So this practice, I learned about this practice because I'm an open source developer when I have free time. So I was working in Zipkin, that is a very popular tracer and distributed tracer. And they use a library in Java called Testcontainers. And this is the example in Python, but they use the Java version. So the Java version of Testcontainers is very famous. It has a lot of stars on Twitter and traction. So it's not the unique implementation. So there is a Java version, a Go one, there is Rust, Scala, Node.js, Go. I'm the maintainer for the Go one, because when I saw about how powerful it was in the Zipkin project, I decided that I was going to use it for myself. So I ported it in Go, because I'm working mainly in Go all the time. So Zipkin is this tracer and has a lot of application nowadays. Has a problem. They need to talk with a lot of different storage, because we take all the metrics from our application, we push them to Zipkin, Zipkin manipulates them, and it stores the metrics to a particular storage. It can be Cassandra, it can be Elasticsearch, it can be InfluxDB. But all of these storage need to be tested in order to be sure that the integration works. So in order to do that, they wrote a set of integration tests, and using test containers, they are running all of them the same across different containers, so they can figure out if all the integration are working in the same way. So if you will like the topic, they have a Twitter account, Testcontainers, and there is a community on Slack that you should probably jump in. They are very nice and friendly, so you can leave your questions and somebody will pick them up. So this is the porting in Go. I'm starting from the Go version because I started it a couple of weeks ago, so it's very simple. It's just the basic that what I think it's useful. I'm adding features based on what I need or what people are asking to have, or there are a lot of people that contributed to the library, so feel free to jump in. So to give you the flavor, this is if you know a little bit about Go, you know that every test case starts with the test word. So I'm testing that the latest Nginx runs. So this is a very basic test. So what I do, I create a container. So there is an object, it's called container request, and it accepts an image. In my case, it's the Nginx image. And I can pass a set of ports that I want to expose. So in my case, we know that the Nginx exposed the port 80, so I'm just passing on that I need the port 80 open. I create the container. I have the ability to specify if we should start the container now or we can start it later. When the container starts, we get back the Nginx container. So what the generic container function is doing is configuring the API, the Docker SDK, and is pushing the request to the Docker API, and when the container is ready, it gets back. So what we get back is the Nginx container, and we get a bunch of utilities and API that are designed to run inside a test. You know, you can do the same using Docker SDK row. You will have all the capabilities you need. What test containers is doing is just giving you an API that gets the flavor you need when you do tests, when you write tests. So one of the important stuff, you need to terminate the container when your test is over. So in Go, we have the defer function that is able to do that. So we get the container and we defer it, and we terminate it when the function is over. So I'm just testing that the Nginx containers returns 200. So I take the mapped port, I take the host, so I have the IP and I have the port, and I configure the HTTP client to send a GET to the root of the IP, and I check if the Nginx returns 200. So this is a very, very basic example. You can start from there and do whatever you want. So what is important to remember here is that the port that we are exposing, we are not mapping the port to a specific port. So when you do docker run -p, you usually do 80 because you are saying, okay, expose the port 80 and map it to the port 80 in my local environment, because you need to reach it from the browser and you need to know which port to get. But if you don't do that, if you do docker run -p and you specify the port, Docker is going to map the port 80 inside the container to a random port that it is available in your host. So this is, you get the flavor about parallelization now, because I can start how many Nginx I want. Obviously, I need to have enough ports to open, but we can open a lot of ports, so usually it works. So you get the flavor of how you can parallelize your container, because you have different containers in every test, and they run and they go away. Just that easy. This is another example with MySQL, just to show you that I'm starting from the MySQL latest images, and I'm exposing the port 3306, the MySQL one, and I'm setting environment variable. They are the same that are in Docker Hub. When you go in Docker Hub and you see the documentation for MySQL, you have the same container. You have the same documentation, the same environment variable, because we are just the object. Container request is just a wrapper around what you can do with a container. So you can mount volumes and you can do whatever you want. An important feature we added, and it's not something that is in the Docker SDK, is the wait for. So the wait for allow you to specify a set of rules that you can use to wait for a container to be ready. As I told you before, the flakiness of the integration tests when you do in a more traditional way comes from the fact that you don't know where the container that you are testing, your target, is ready to handle your request. So this is the way you have to programmatically say what you want. So I think that programmatically is the word that is important and is the one that changed the game here. Because when we use Docker Compose, or when we control our environment from the outside, we don't have much control. Now, what we are doing here, we are bringing the provisioning inside the test case itself. So we have code there, and we can do whatever we want. So it's just a matter of being good. So what we are doing here, we are waiting for a log entry to be there. So we know that when MySQL starts, the last log message that we get is port 3306, community MySQL edition is there. When that entry is in the log, it means that MySQL is ready to handle the traffic. So you can code your wait function, and it can be as complex as you need it. And yeah, when we have the container, it's the same as we did before for Nginx. We take the host, we take the IP, we configure the SQL client, and we go from there. If you are more familiar with Java, I have a few code that will help you. And the Java version, as I said, is the most mature one, is the first one they developed, so it has way more features. So I added some of them there so you can get the flavor about what you can do. So it's the same, it's just using the Redis images, and it is exposing the port 6379. So we are using JDis, that is the JavaScript, the Java Redis client for Redis. We are configuring it with the container, and we are running a test. Our test is very simple because it's just finding a key inside Redis. So we are setting the value and we are getting it out. Very simple. You can also exec inside a container. So when you have your container running, there is an exec in container function that you can leverage to do whatever you want. In this case, we are creating a new file. You can also set environment variable, as we was doing in the Go version, or we can share volumes inside the container. This is something that is not supported in the Go version, for example, but we will make it happen. This is how they handle the wait for. So when you have your container, you expose the port and you wait for. In this case, it's not you are not waiting for a log entry, but you are waiting for HTTP endpoint to return whatever you need. So in this case, it's 200 or 301. You can also build containers from a Dockerfile programmatically. It is very powerful. The Go version doesn't support that yet. I think I have an open issue to make it in a way that will work in Go. I think I'm going to use BuildKit and embedding BuildKit because it's in Go. Like in the Go environment, everything is very easy because Docker is in Go, so we have all the libraries and all the capabilities we need. We can embed them and create whatever we want. So this is a more complicated example. I left a link over there. You can check it out later. it's taken from the Zipkin integration. So as I told you before, Zipkin supports a lot of different backends. This one is the Elasticsearch storage rule. So this class is executed every time you run a test against Elasticsearch, and it configures the Elasticsearch container. So for this particular case, what it's doing is taking the port and the image, and it's injecting the logger, and it's running the test. So, just as the others. One of the projects that went out close to test containers was MOBI Ryuk. MOBI Ryuk is a library that we use to clean up our mess. So, as you probably now realized, you are spinning up a lot of containers, and when your test is over, you defer the termination and they go away. But sometimes it doesn't work like that, because we are humans and they are computers, so we don't talk to each other that well. Ryuk is able to delete. It waits for a little bit longer than your test container, and it's able to delete containers based on their label. So Ryuk stays there when you end all your tests, and if one of the tests panics and the defer function isn't called, Ryuk is there to catch up and clean up your mess, or our mess. Now that we have everything inside the code, we can write our utility functions. So I'm not gonna tell you to do all that generic container and container request all the time in all your services. What you can do, you can write a package that supports your tests, and you have your function that says spin up my Kafka container or my Kafka and my MySQL and wait for it to be ready, give me the URLs and so on. So this is an example. Even Java and Go there is a pull request that is not merged yet, has a concept of pre-canned container. So based on the feedback and the experience that the community is doing with test containers, we are creating ready-to-go containers for the most famous services. So MySQL, Kafka, and they are way easier to use because they have particular utilities for that particular service. So for example, the MySQL one, the object also has a getClient function, and the getClient returns the SQL client configured to reach the container. So we get the MySQL, we run the MySQL container, we do MySQL getClient, and we have the client ready to go. Time for a demo, because I'm a DockerCon, so I need to deliver a demo. That's how it works. So I wrote a very easy application in Go. It just exposed a single entry point that is called health. And as you probably know, it's very important to have an health check that works, because all your automation relies on the healthiness of your application. So what I'm doing here in this example, I'm just having an health check that always return nil, so no errors, so we are good. In case one of the checks, in this case we have just one, but in case one of the checks doesn't work, won't work, it will return a status code that is different, that is 500, so it's different than 200. Now, I'm gonna add a function. Oops. I'm gonna add a function that is called check MySQL. Check MySQL is an health check that I will add to the list of health checks that my application runs. And what it does, it takes a bunch of configuration from where my MySQL is, and it checks if the MySQL is open. This is when you design a health check, it's important to realize what you should health check to. So usually you health check what is important for your application to work. So if your application relies on MySQL, you should check if your MySQL is up and running. So that's what we are doing. Our application really relies on MySQL. So we are going to do another check that is, oops. I can type. Obviously, I'm just faking stuff here, but these are the configurations that usually come from the outside, so where your MySQL is. Looks like I forget the host. And that's it. So usually what you do at this point, you recompile your binary and you call the health check and you verify that everything is running. But what we can do, we can code the integration test now. So I'm going to create my main.test. And what we can do, we can write our first, oops. We can write our first test. So we need to check if our check functions, that is way down here, works as expected. So if it returns an error if my MySQL container doesn't work. So in order to do that, I'm using test containers, obviously, because that's the point of the talk. So I configure my container with the MySQL latest image. I expose the port 3306. I configure it with the right and secure root password that is root, and database is database. I wait for the log, as we saw previously, and I start the container. And I defer the container in order to have it removed when I'm happy. Now I take the host, so the IP of the new container. I take the port, and I configure my check MySQL to see if everything is good. My expectation for this test is that my check function won't return any error. So I'm checking that if there is an error, the test should fail. I forget to import the wait library. So let's run it. Well, you know what? This is the demo god. It's against me. Okay. So let's run it. It's going to take a while because it's going to pull the container and run the container, at least the first time. But just to show you that I'm not lying, what's happening here, this is my Docker. So as you can see, the test succeed. And I did Docker PS, and I see that I have one MySQL container running. And I have the Ryuk running, that is the ghost that is waiting to clean up the test suite. So if I do Docker PS, now they are still there. Yeah, they shouldn't be there. But yeah, the idea is that every time you run your tests, you check against brand new and fresh containers, and you are able to delete them, and you can parallelize your tests, because now every single unit test is pointing to a container that is used by just that function. So I'm going to share my slides some way, probably on Twitter, and the conference, DockerCon, will probably ship them. So there are a bunch of links with blog posts and links that you can check about test containers and how it is used across different languages. And thank you. So if you have time for questions. So if you have any of them, just please go to the microphone because everything is recorded, so it will be recorded as well. Please, come on.
So I was wondering how this Riot works in a CI CD environment. Like, do you have to run the container in the background all the time, and then it just looks that there's containers that it can delete, or how would that work?
No, it spin up since when you spin up a container. So when test container starts the first container, it starts Riot, and
so it started from within the Go code then?
Yeah.
So even if it panics, the container will be there.
That's why there are two separate containers.
Got it. Okay, cool. Thanks.
Thank you.
Yeah, so it seems like it took like a while just to run one single test. So do you sometimes like bring up a MySQL instance container for like multiple tests? Or do you just like massively parallel, like if you have hundreds of tests, you have like 100 containers at once?
Yeah, no, sometimes you can create a container and I defer the container through multiple tests because it makes everything faster. But usually, integration tests are well known to be slow. So this is no magic. It's just gonna give you all the parallelization you need. So yeah. And it takes a while when it needs to download a lot of stuff, but usually when they are in your CI or laptop, they are cached and good to go.
So piggybacking on the same one, so let's say that I had MySQL test and you expose some port 3000, then you run another test and that one says export port, the same port number. How do you say just generate a container for me? Tell me what the free port number is and just use that so that you can run 6 or 8 or 12 at the same time.
Yeah, that's how Docker works. So if you don't specify when you expose a port, you can decide if you expose a port to a static one in your laptop. But if you don't specify anything, it's gonna take a random one.
And then you just ask the container for the port.
Yes.
It comes back like you had in your test.
Yeah, in the example, when I do expose 3306 or 80, I'm actually not providing my port. I'm providing the one that I would like to be exposed.
I got you.
And Docker is picking a random one, and when you do get mapped port, it gives you the one that it exposed.
Cool.
That's why you can run all the containers you want.
I was actually curious. I have a need for this in a Python project, actually, and I was wondering, you may have said this, what does the test containers library give you as opposed to just using like a Python Docker implementation that allowed me to create containers? Is it the Ryuk that handles the cleanup? Is that what it provides additional to that?
Yeah, it provides a community. It provides you the flavor of an API that is designed to be test-driven. So if you run you end up with a lot more verbosity, but you're.
Yeah, I was just asking because the Python, like you were saying with the Go, the Python one doesn't look like it's nearly as far along as the Java. Version.
Yeah. I mean, I like to use test containers because I get the right function that usually I need for. The Java version is super flexible, so you can almost do whatever you want. The others are catching up, so I think it's good to, but you are free to use the native one, let's say. Thank you for the question.
I was wondering about tests that require multiple containers, I guess, and usually through Compose or something, you kind of get the network set up. Is there facilities for that as well?
Yeah, the Java version supports Docker Compose mode. So you give the Docker Compose your path, and it will spin up the containers. And you have capabilities about programmatically add the wait for and all this kind of stuff. The Go one doesn't have it, but that's what I was thinking when I had the slides about writing your own utility functions, because in the utility functions you can create a bunch of containers that you need. You can set the right wait for. You can, if you if you combine, the wait functions are really flexible and the interface is very simple. So you can pass a container that you create previously as a wait function and you can wait for that to be ready and cascade down. So just the fact that you have the code, it allows you to do whatever. So yeah.
Okay, thanks.
Thank you. By the way, yes, the Java version, you give the Docker file, the Docker Compose file, and it parses it and works. Oh, that's good. So thank you. Let me know if you need everything. Thank you.